Hello and welcome to another episode of AI in 5 with Snorkel. I'm Shane Johnson, and today I want to talk about fine-tuning embedding models. Before anything, I would get started by checking out the MTB leaderboard on Hugging Face. This changes fairly often, right, with new leaders, maybe not every day, but at least every week, every month. What you see here is a subset. We sorted them by retrieval score, and I filtered it to only include the open models for fine-tuning. What's fascinating is look at the enterprises that are producing embedding models: Salesforce, Snowflake, NVIDIA. First things first, pick a handful and see how well they do with your use case out of the box, right? We know they're going to be fine-tuned, but you might as well start with one that does the best out of the box. Anecdotally, we work with customers fine-tuning BGE models quite successfully. The next step, which can sometimes be overlooked, is see if you can't identify where specifically the embedding model struggles the most. Naturally, we want to create an embedding model for a specific domain to improve retrieval accuracy, but you may find that there's certain types of prompt chunk pairings, right, or question and relevant chunk pairings that it can struggle with. We are working with a customer who was building an AI copilot for document QA and financial documents, and it turned out questions that needed an understanding of dates in specific clauses is where it was struggling quite a bit. So as we began to curate training data, we made sure to include examples that would help with these types of questions. Step 3, this is where the most of your work is going to take place, is curating the training data. At a high level, we're looking at prompt chunk pairs. In practice, this is a question and a chunk which has relevant information that the LLM can use to answer that question. You want good and bad examples, especially the tricky ones. You would often hear these described as hard negatives, but we're looking for examples where on the surface it would appear that this prompt and this chunk are a good match. But if we had an SME look at it, they might realize very quickly, it looks like a match, but it's really not. The more of those, the better. In terms of where you get it, you can certainly ask SMEs for common examples, frequently asked questions, things that they've learned over time. And then given a whole bunch of chunks, you can use a foundation model to generate questions, right? You can do this synthetically to help expand or augment your training data. But do keep some eye on the format. We have prompt chunk, which is typically all matches, and then you can shuffle them to create some negatives. You can also kind of explicitly add positive matches and negative matches, right, with a label. Or I'd say, probably more common is to create triplets. So you have a question, a relevant chunk, and an irrelevant chunk, right? Lots of these triplets can help fine-tune our embedding model. Step 4, choose a loss function. I wish there was a silver bullet, or I could give you some really grand advice here, but it really comes down to the format of the training data. So depending on what you've curated, whether it is positive pairs, triplets, those will determine which loss function you use. Admittedly, for some of these formats, there may be 3, 4, 5 options in terms of loss function, but typically there's 1 or 2 that are the most common, right, or considered better or newer that you're going to focus on, and I put a handful of examples here for you. Step 5 is to put that training data to work and fine-tune your embedding model, and it's really fairly straightforward. I have kind of a condensed example on the right here, which actually came from a great blog from Hugging Face on fine-tuning embedding models. You can see it's fairly simple. Pick a model, upload your data set, choose a loss function, and then perform the fine-tuning. With Snorkel Flow, we also integrate with platforms such as AWS SageMaker and Databricks Data Intelligence Platform to help streamline the process. But the net here is you really want to put a lot of effort into curating high quality training data, right? The better the training data, the more accurate your fine-tuned embedding model is going to be, and thus the more accurate retrieval is going to be in your RAG pipeline. Until next time.